So my name is Andy Clegg. I am Spectrum Engineering Lead at Google. At Google, the Spectrum Engineering Lead combines a bit of engineering know-how along with our policy efforts to get our products and services that rely on the radio spectrum off to market, help them get off to market. As you can imagine, spectrum access and coexistence and a number of other things are very important to getting good product experiences with Wi-Fi and cell phones and things like that. And so a lot of times there's a little bit of regulation and engineering that has to go into getting all of these things approved. So as you can imagine, Google is involved in a lot of different things. And we are pretty heavily invested in various wireless technologies. So, for example, we make Pixel phones, which have a lot of spectrum use in them. They're like typical cell phones. They use a multitude of bands for wireless broadband, but they also use GPS and GLONASS for positioning. They use Bluetooth. They use ultra wideband in order to help locate your phone or open your car. They use RFID technology at some of the lower frequencies in order to scan things. They also use spectrum even for wireless charging. When you put your phone on the little wireless charger, there's actually a low frequency band that's used for that. We also manufacture and sell a lot of Wi-Fi technology, like our Nest Wi-Fi products and things like that. We also have a company called WebPass that specializes in getting information from buildings to building in urban environments using 70, 80, and 90 gigahertz millimeter wave technology. For a while, we had aircraft that could stay aloft for weeks at a time, providing broadband service, and we had uplinks and downlinks that we needed to support for those. We had balloons called Loon that could provide cell service and other technology in areas that had been hit hard by natural disasters and things. So there's a very large variety of things that my company is involved in that rely on spectrum. An additional interesting application we have that involves the radio spectrum is what's called a spectrum access system. Google is one of the 6 operators of spectrum access systems in the Citizens Broadband Radio Service band, the CBRS band at 3.5 gigahertz. The purpose of a spectrum access system is basically to act as essentially a traffic cop to avoid the Citizens Broadband Radio Service devices from causing interference to the incumbents in the band. The incumbents in the band, of course, are mostly the Department of Defense. They operate military radars, mostly on ships, but they do operate some land-based ones. And so Google, along with our 5 competitors, have developed spectrum access systems that basically are aware of where the DoD operates and when they operate their radars. And before a Citizens Broadband Radio Service device can transmit, it needs to connect to our spectrum access system or another spectrum access system and say, hey, this is where I am. This is how much power I want to run. This is how much bandwidth. These are the frequencies that I'd like to run on. Can you tell me if it's okay to operate? And the spectrum access system will look at its knowledge of where the incumbents are operating and what kind of protection criteria they have. To what extent do you need to protect them? And it will provide a reply to that Citizens Broadband Radio Service device and say, yes, it's okay to transmit, or no, don't transmit where you are because you might cause harmful interference to incumbents. If we determine it's okay to transmit, then that device actually has to check back in with the spectrum access system on a regular basis. And depending on where it's located, it may have to check back in with the spectrum access system every few minutes in order to ensure that it can continue to operate where it is without causing interference to to the incumbent operators. But in the back end, the spectrum access system actually does a lot, and it requires a lot of computational resources to do it. Here are some of the challenges. The spectrum access system doesn't just look at the interference from a single device to a ship, for example, at a specific point off the coast. That may be, one of the things it's trying to do is protect that particular ship from interference at a given time. But that's not how the spectrum access system looks at it. Because first of all, spectrum access system doesn't necessarily know where a ship is going to be at any given time. The DoD doesn't tell us that. And it doesn't tell us, the DoD also does not tell us when the ship is going to operate its radar. So every night we take all of the emissions coming from most of the citizens broadband radio service devices. We run propagation models and determine, the amount of power they have pointed in different directions. And we have to calculate what the total aggregate interference is from all of those devices into millions of points, including every possible pointing direction of the DoD's radar at that time. And every day, new CBRS devices join in. New devices are authorized every day. And so every night we have to redo all of the calculations that take into account the new devices that have appeared and the ones that are no longer registered, and redo the calculations. And then we have to exchange data with all of the other spectrum access system administrators so we can all be on the same page with regard to protecting the DoD. So the CBRS band is 3550 megahertz to 3700 megahertz. So it's 150 megahertz wide. So a pretty good chunk of spectrum. Now the bottom 100 megahertz of that, the 3550 to 3650 megahertz band, is where the priority access licensees have to operate. They can't operate in the upper 50 megahertz. They have to stay in the lower 100 megahertz. And in any given area, the priority access licensees can only use up to 70 megahertz total. So there will always be an additional 30 megahertz in the lower 100 megahertz available to the general authorized access operators. The other point is that the DoD primarily uses the lower 100 megahertz as well, 3550 to 3650. So most of the work that the spectrum access system does to protect DoD incumbents has to do with protecting the lower 100 megahertz of the band. There are some fixed satellite service, space to earth links that operate in the upper 50 megahertz that we do have to protect as well, but that's not nearly as challenging or as dynamic as protecting the DoD. Devices are now not only operate at the 2.4 gigahertz band and the 5 gigahertz band, but also operate in this new 6 gigahertz band, 5925 to 7125. In addition to my regular role at Google, I hold a position as Chief Technical Officer for the Wireless Innovation Forum. The WInnForum is an international standards organization. One of the recent activities of the Wireless Innovation Forum was to develop the standards that the U.S. Citizens Broadband Radio Service, or CBRS, operates under. And so all of the standards that govern how spectrum access systems operate and how CBRS devices talk to the spectrum access system, those were all developed in the Wireless Innovation Forum as a set of standards. The interesting thing about developing those standards is that it essentially involved everybody who was going to use the CBRS band. So it involved the companies that were going to build and operate spectrum access systems. It involved the companies that were going to build and sell citizens broadband radio service devices, so the base stations effectively in the band. It involved a large number of entities that were going to operate in the CBRS band, so big telecom companies, all the way to the wireless internet service provider, the WISPs that typically provide rural broadband. And very interestingly, the Wireless Innovation Forum, when it developed its CBRS standards, also included a lot of participation from the government itself. As you'll see, the CBRS band is shared between non-government users and government users. In particular, the government users are mostly the Department of Defense. You're dealing with a lot of conflicting objectives and goals. The objective of the DoD is to mostly protect their systems from getting harmful interference. The objective of those who want to operate in the CBRS band is mostly to get as much spectrum as they can use at a given time in a given place. And so we had to balance a lot of competing interests in the Citizens Broadband Radio Service as part of developing the WINForum standards. And it took time. It took us almost 3 years to fully develop the standards, and there were a lot of contentious issues, but we've worked them all out, and the CBRS band is now fully operational. And we have never caused any harmful interference to the DoD, so that's good. That means our standard is working. The spectrum world really involves a whole set of skills and not just one skill in particular. So it is not just engineering. And in fact, in a lot of ways, the best spectrum managers I've known, engineering isn't their biggest skill set. They may have been trained as an engineer or perhaps not. I think the ability to be a diplomat, to see things from other people's perspectives, because mostly spectrum management is about learning how to get along with other users of the radio spectrum and not interfere with each other. The interference calculations, those are where the engineers come in, and they can determine whether something may or may not interfere, or if there is a problem, they can track it down. Students from a variety of backgrounds, certainly those that are interested in the law, those that are interested in economics, in business, and of course, people interested in engineering, all could find a role in the spectrum management field. So I think it really is something that needs people and experts from a large variety of areas, not just engineers. And in fact, if you just get a bunch of engineers in a room, usually bad things end up happening. They don't really look at the practical considerations involved. So I think spectrum management really is something that almost any field, you could apply the skill sets that you're learning in that field into the spectrum management world.